Welcome to our fifth and final video for our fifth class time set of instructional videos. I wanted to start this video with doing some practice for both writing names for structures that are given to you and then drawing structures for names, because this is how you might be tested at some point. So let's go ahead and start with this structure over here. We've got to find the longest base stem chain, so we can go ahead and start numbering from the end closest to substituents, and that would be on the right side. So it doesn't matter which of these three carbons we number 1. 1, 2, 3, 4, 5, 6. It is an octane because there are 8 carbons in our longest chain. There are 2 methyl groups at carbon 2, so we would have to call this 2,2-dimethyl octane. How about this? Well, we have to start from the side to which we're closest these substituents. So 1, 2, 3, 4 is a lower set of numbers than 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8. Another octane, except this one happens to be 4,4-dimethyl octane. How about this curious compound? Well, we have methyl groups that are equal length from our longest base stem chain. We want to choose the base stem chain that has 3 groups instead of the base stem chain that has only 2 groups, albeit one of them is branched. And so then we have to use our first point of difference. So we number from right to left because this group comes at a lower number than if we were numbering from left to right. So 1, 2, 3, 4, 5. It's a hexane. So now we arrange our groups in alphabetical order. Ethyl comes before methyl. So this would be a 3-ethyl 2,5-dimethyl hexane. So our final example where we're trying to find out a name for this compound, we've got a number from right to left again. So 1, 2, 3, 4, 5, 6 is a hexane. Again, there are 4 methyl groups, 1 at carbon 2, 2 at carbon 3, and 1 at carbon 4. So this would be 2, 3, 3, 4 tetramethyl hexane. All right, so having solved that, now we go to what I consider to be easier, to draw a structure from a name. So if we're given 2,2,4 trimethylpentane, we know it's a 5-carbon base stem chain. So 1, 2, 3, 4, 5. At carbons 2, we have 2 methyl groups. Doesn't really matter how we put them on there. And then at carbon 4, we have another methyl group. How about 4-ethyl 2,2-dimethyl hexane? Well, hexane is 6 carbons. 1, 2, 3, 4, 5, 6. We have 2 methyl groups at the 2 carbon. 3, 4 is an ethyl group. There we go. And then how about 3-ethyl 7-methyl 6, 1,1-dimethyl ethyl decane? Well, decane is 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And where do we go? We can number 1, 2, 3. Here's an ethyl group. 4, 5. At carbon 6, we have a methyl ethyl group. 1,1 dimethyl. So there we go, 2 methyl groups on that one carbon. And then at carbon 7, we also have a methyl group. So hopefully this has been good practice with naming structures and drawing structures. We'll move on to one last topic for this video, and that is solving an organic dilemma by creating 2 equations and 2 unknowns. Let's say, for example, that you're lucky enough to isolate an organic compound and subject it to elemental analysis, a technique whereby you can figure out the percentages of carbon and hydrogen in it. It was determined that the compound had 87.93% by weight carbon and 12.07% by weight hydrogen. Mass spec gives a formula weight of 150.26 grams per mole. So one asks, how can the compound's molecular formula be determined? Well, you could assume that you have 100 grams of material. You would know that 87.93 grams of that consist of carbon, and 12.07 grams, that is the balance, is made up of hydrogen. Well, you could take 87.93 grams of carbon, divide it by carbon's formula weight, 12.011 grams of carbon per mole of carbon, and you get the moles of carbon at 7.32. You do the same for the hydrogen. Take the 12.07 grams of hydrogen, divide it by 1.00794 grams of hydrogen per mole of hydrogen, and come up with 11.97 moles of hydrogen. Then you could create 2 applicable equations for your the formula of your compound CXHY. You would know that X times 12.011 grams per mole plus Y times 1.00794 grams per mole would give you the formula weight of your molecule of 150.26 grams per mole. And you know the ratio of X to Y would be the ratio of the number of moles of carbon to the number of moles of hydrogen. Then you simply solve for X and Y, and you should get X equals 11 and Y equals 18. Another way that would be simpler probably to do is to take 0.8793 and multiply that by 150.26 grams per mole to get the amount of carbon making up that formula weight, and simply divide by 12.011 grams per mole being the formula weight of carbon to get X. To get Y, you do the same thing. Multiply 0.1207 by the formula weight, 150.26 grams per mole, and divide by hydrogen's formula weight of 1.00794 grams per mole to obtain Y. So that pretty much concludes this 5th video. I will see you shortly for the 6th class time session of videos.